Where, when, and how to see shooting stars, the Perseid meteor shower in August. Traditionally, we observe shooting stars on August 10th, but the peak rarely occurs exactly on August 10th. This year, for example, the peak will be on the night between August 12th and 13th. Therefore, all nights between August 11th and 14th are good for watching shooting stars. However, there is a complication: the moon. Although it is not full, it is at its first quarter, and its light can brighten the sky, making it difficult to see the fainter meteors during the early part of the night. However, after midnight, when the moon has set, you can look for shooting stars. This year, about 90 are expected per hour, so there is a good chance of seeing many. For optimal observation, it's essential to find a dark sky. If you try to see them in the city, you'll see very few except the brightest ones. Move away from the cities and find a spot far from street lamps and artificial lights. Also, avoid using smartphones, as their light not only distracts you, but also constricts your pupils, making them less sensitive to the faint light of the starry sky. Shooting stars can appear anywhere in the sky, but it's advisable to look towards the north-northwest, as they seem to come from the direction of the constellation Perseids. To find it, look for the constellation Cassiopeia, which has a W shape. Perseid is located in that same area of the sky. When we talk about shooting stars, we're actually talking about the Perseid meteor shower. The term shooting stars is a misnomer, just like other traditional names such as hairy stars for comets or wandering stars for planets. Shooting stars are actually meteors, which are bright phenomena caused by the friction of a rock fragment, meteoroid, burning up in the atmosphere. The light we see is generated by the heating of the rock fragment and the surrounding atmosphere. The color of the light emitted by meteors generally appears white because our eyes don't distinguish well between different hues. However, with specific tools like spectroscopes, we can see that the color can vary depending on the composition of the meteor and the atmosphere. For example, iron produces a yellow light, while red might come from the oxygen or nitrogen in the atmosphere. Every day, many meteoroids burn up in the atmosphere, but we don't always notice them because many of these explosions occur during the day or over the seas, or because we are not constantly looking at the sky. Some times of the year see a significant increase in meteors, creating meteor showers that seem to come from a single point in the sky, called the radiant, within a constellation. The Perseids, for instance, seem to come from the direction of the constellation Perseids. In the past, meteor showers were a mystery, and they were thought to be atmospheric phenomena. It was in 1833, during a Leonid shower, that astronomers realized the radiant moved with the sky, indicating that the phenomenon was related to something happening in outer space. In 1866, Italian astronomer Giovanni Schiaparelli discovered that the Leonids were associated with the passage of a comet, Comet Swift-Tuttle. It was understood that comets, when passing near the sun, release rock and ice fragments that remain in orbit, and when Earth passes through these trails, the fragments burn up in the atmosphere, creating meteor showers. The Perseids are linked to Comet 109P Swift-Tuttle, discovered in 1862 by Horace Tuttle and Louis Swift, and confirmed as the source of the Perseids by Giovanni Schiaparelli. This comet has a very large nucleus, over 25 km, and leaves behind a large numbers of fragments during each pass near the sun, which we can observe on clear summer nights. That's all for today. If you liked this video and found it useful, give us a thumbs up and share it with anyone you'd like to take stargazing. Subscribe to the YouTube channel and turn on notifications so you don't miss upcoming content.